I'm Jenny from Potomac Highlands Regional Jail, and we're going to talk about volume. Okay, listed here are the formulas for volume. Now, we're not going to directly talk about each formula because these formulas are provided on the task reference sheet. So all you need to know is how to plug into these formulas. What your students should know is the formulas for perimeter and area because those are not provided. So you do want to make sure you take the time to practice some of those formulas and that you do have those memorized. Okay? So what we're going to do first is Robert Holden is going to give us an example of using volume of a pyramid.
I'm Robert Holden from North Central Regional Jail. I'm going to show you how to find the volume of a pyramid. When we look at this, the volume is equal to 1/3 the base. The base is a square times the height. When you're doing these, you want to make sure you have the true height. The true height is going to come from the peak straight down. It's like dropping a plumb ball from the point down to the center. You need to be careful. Sometimes on the test, they might give you this angle here. That's not the true height. The true height is coming straight down. So if we set this up, we're going to have the volume equals 1 times the base. The base is 6 times 6, which is 36. There's some different ways you can do this. I prefer to set it up as a fraction all the way, times 12, the height, over 1. Now, if we look at this, we can do some cross cancellation. 3 will go into either one of these. So I'm going to take 3 into 36 will be 12. Then we multiply straight across the top, which would be 144 over 1. 144 cubic, whatever you're measuring in, cubic centimeters, cubic feet. And that's how you find the volume of a pyramid. Next up will be Jamie Oates from Central Regional Jail.
Hello, Jamie Oates here again with you from Central Regional Jail. If you watched any of the early videos, especially from the content area of volume, you heard Jen say we needed to know and have pretty much committed to memory the formula for area. This is a prime example of that. You can find a question like this on the task, on the readiness assessment as well. And this is one where we need to know that formula, area, which is length times width. Okay? This is a word problem. Let's go ahead and look through this real quick. A 20-meter cable is being used to measure a square plot of land around the perimeter of the plot. It is placed 14 times on one side of the plot with 7 meters of cable extra at the end of the first side. What is the area of the plot of land in square meters? A couple of things. This is something I sort of tell my students, attributing that to football. I coach football, and we're all the time telling our athletes to focus on the details. This is a word problem. A lot of people are scared of word problems. All we have to do is look at the details. We have to find out what's important, what's not important, and go from there. First thing is we've got one question mark, which means we only need one answer. Okay, what's the question asking us? We're looking for the area. Okay, we established that. Important things within the problem. I'm using a 20-meter cable to measure my area width. Okay, it's placed 14 times on one side of the plot. Okay, and here is some important information. I have 7 meters of cable left over. So if you watched the order of operations unit earlier, or have already seen that, you'll see that this is more or less an area problem with a little bit of order of operations kicked in. All right, so we're going to take this 20 meters, this order of operation. We're going to take the 20, all right, and I'm placing it around 14 times. So I'm going to multiply that times the 20 meters, the length of the cable. Now here's another thing. I'm going to have 7 meters left over, so I'm going to subtract. Once I get this total here, once I find this product, I'm going to subtract that. 20 times 140 is, if I had a calculator, needed to, I would find it's 280. I'm then going to subtract that 7. So look, order of operations, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. I've completed my multiplication. All that's left is my subtraction as I funnel down to my final answer. 280 minus 7 is 273. Okay, now, I like to draw pictures. I'm a visual type guy. So I'm going to draw a picture of this plot of land. All right? It says, what kind of shape is it? It says what? It's a square right here. All right, we know that a square has 4 equal sides. So one side, the side we've measured is 273 meters long, correct? All right, so formula for square, length times width. You can use that, or also for square, side squared. So you've got two different formulas that are going to give you the same result, the same answer, all right? So I'm going to take the 273 right here, my answer, funnel down to that. I'm going to take 273, I'm going to multiply it to itself, or you can do this, 273 using the calculator, square it, and I'm going to find in my final answer, the area equals 74,529, that is in meters and it's squared. They don't ask me, or they're not concerned with the unit of measure here, but I know my answer. My answer here is C. There's a very brief, very good representation of area within a word problem, and a lot of different avenues, directions we could have taken that we took to solve.
Hey, this is Jenny at Potomac Highlands Regional Jail. I'm going to show you another practice problem working with volume. The question here states the diameter of this cylinder is 6 inches and it has a height of 7 inches. A cap needs to be designed in the shape of half a sphere for one of the ends. Find the volume of the cylinder and the cap. Use 3.14 for pi. This question may seem a little bit wordy or a little bit difficult, but it's really not that bad at all. What you have to be careful is that you make sure you really read the problem to answer correctly. So let's get started. Let's begin by solving our formula for the volume of a cylinder. Okay, we're going to scroll down here a little bit. And what we're going to do is, we know over here that they told us our diameter is 6, and we have a height of 7. Okay, so we're going to do volume is equal to 3.14 times the radius. Now here's where it can get a little tricky. It's easy to want to use this 6, but the 6 is the diameter and we need the radius. So we're going to use 3 squared because the radius is half of the diameter. Okay, and our height we know is 7. Okay, so we're going to use our calculator, and all we're going to do is type in 3.14 times 3 squared, which we know is 9, times 7. And we're going to get an answer of 197.82. Okay? So that gives us the volume of our cylinder. Now we also need to find the volume of the sphere, the cap. Okay? So if we look at this equation, we have volume is equal to 4 over 3 times pi, which is 3.14, times, again, our radius, which is going to be 3, and this time we're raising to the 3rd power. Okay? So, again, if we do this, we'll do 4/3 times 3.14, and 3 to the 3rd power is 27. Okay? And if we put that into our calculator, multiply this out, we're going to get an answer of 113.04. Now, if you look at your answer choices, it's very easy to want to choose item C because those are the 2 volumes. But if you look back at the question, okay, we need to find half of the sphere. Okay? So what that means is we need to take half of that answer, which is going to be 56.52. So the actual answer here should be choice D.
Howard Meeks, St. Mary's Correctional Center. Continuing on with some sample problems or types of problems that you may encounter dealing with volume. Farmer Brown is buying a new water tank for his farm. His current tank is a cylinder that is 5 meters high and 6 meters across. At the store, he's given a choice of 2 tanks that he could purchase. And so we have a couple options of choice. The first one has twice the height of its current tank but keeps the same width. The second one has twice the width of his current tank but keeps the same height. If both tanks cost the same amount of money, what is the greater volume of water the 2 tanks could hold? So the first thing we're talking about obviously then is volume, and I'm going to have to set up some problems. And since I'm doing some comparison, I'm going to have to maybe do my problem more than once so I can and see the difference in the tanks. A quick reminder of volume. We're so often used to saying, beginning with this, and basically you find the area of the bottom, and then we're filling it up. Okay? So in this case, it's length times width times height. And that's one that most students are comfortable with. Now we're talking about a cylinder, so what's different? Well, the base, or what I'm starting to fill up, is what's different, and it is in the shape of a circle. So the first thing I'm going to have to know is the volume for a cylinder is, that base is going to be pi r squared, or pi times the radius squared. And as you've heard others talk about, we'll use the number 3.14 in place of pi. Okay? Or the shortened, condensed version for a number that continues on a long way. Okay? And then, as you fill it up, it's going to be this circle filled up and to a level, or the height. So that's where you get volume equals pi r squared times the height. Okay? So once we've established which formula we're going to use, and I just wanted you to see that, you're not going to have to memorize it, again, as it's been mentioned in the video here, that it's part of the task test, but I just wanted to show you where this comes from, that these formulas don't just come out of magic in thin air, that there's some logic behind it and why they are effective. Okay? Now the question is, we have two tanks, okay? And we're going to compare it. So the first thing I'm going to do is probably talk about the very first tank that the farmer already has. So I have some kind of comparison. And in the problem we notice that it's 5 meters high. Okay? And 6 meters across. And so that would be its diameter all the way across, and 6 meters. And that's going to give me a reference point as I move on to the other two tanks. So tank 1, and again, I'm also a visual learner. And the first one has twice the height, so instead of 5, we're now going to be 10. But it keeps the same width, so we're again going to be 6 meters across. All right, that's tank 1. Tank 2, the second one has twice the width, so it looks like me, it's going to be a little bit fatter. Right, maybe a lot fatter, but that's all right. Just remember in geometry, round is a shape, so I am in shape. Okay, so the second one has twice the width. So in other words, if this is 6, this is going to have a diameter of 12 meters, but it keeps the current height, which was 5 meters. Okay, so now that we've got a visual, now it's just simply what I call the Glade commercial, showing my age. We're just going to plug it in. So we found the numbers that we're going to use. Again, being careful, as we seen in another video, that you find and use the radius and not the diameter. So the radius is halfway across. So for tank 1 then, I'm going to be multiplying the volume equals 3.14 times the radius squared, or 3 squared times 10. And tank 2, again using our formula, is 3.14. My radius, half of 12 is 6, so it's going to be 6 squared times 5. And now, doing our calculator work, let's go ahead and see what we determined through our process of setting up and solving the problem. 3.14 times 9, which is 3 squared times 10. And this is 282.6. And our units was meters, and it's volume, so it's cubic for 3-dimensional. That's what I will tell my students. And let's look at tank 2, 3.14 times 36, or 6 squared, times 5, and it's 500 and 65.2 meters cubed. Going back up, looking at our choices. The one that holds the greater volume would be A, 565.2. Of course, the unit's not here on the answer, but we know it would be there in meters cubed. All right, hopefully that helps you. It doesn't hurt to use your scrap paper when you're working on your test, set up your problems, and that way you catch little tricks like the use of diameter instead of radius and things like that. Hopefully that helps you a little bit understand how to use cylinders, the formula for cylinder, and another example of a volume problem.